Yeah.
Okay, so your waves. This would be a P wave. This whole thing, yep, is QRS complex, and this would represent a T wave. So, somewhere in between the end of the T wave and the beginning of the P, this to after the end, so something like about here. This would be one cardiac cycle. This is one heartbeat. Everything that's going on in one heartbeat. So remember, the P waves would represent where the, what's going on? Atria depolarize or contract. QRS is where the ventricles contract, but the atria are relaxing. And T wave is where the ventricles contract and depolarize and contract. Okay. So you know what's happening in each. Now, in order to do measurements of voltage, when it asks for something in millivolts, you're measuring up. You're measuring up and down. So, if it asks about the millivolts of the P wave, what you can do is you can either take a ruler and measure from an approximate baseline, which let's say is about, I don't know, this is a little funny, but maybe about here. This one's a little funny, so it's hard to say. So it's kind of like the basic line where if you have a nice one, everything kind of comes back down to.
Okay, not like from the bottom of the...
Well, usually it's there. Let me see one. No, in that case, yeah, I would still go like here. So it might not be at the bottom of this, no. It's more like going across the P. Yeah, this is a good one. Now, see, this is the kind of thing you're going to see. See this? See how it's shaky, and then it's starting to go like up and down? Right there. Because you see like this big line? That's the baseline. And then if I just keep, continue it, see where I'm at? That's the baseline. So I'm having a little bit of a hard time because I got some stuff kind of, it's starting up here and it's coming down. This is beautiful. Yes. That's baseline. So, can I use this?
Sure.
Okay. All right. I know. Maybe they have more to spare. They'll give you. Okay, so here, this would be, and maybe somewhere here, my one cardiac cycle. So you have the P, the QRS, and the T wave. Now let's do measurements of the P wave. Again, you can measure, you always want to do the metric system, millimeters, which this is in inches, down here is inches, so, and I could measure it, I can measure like this, or what's even easier is just to measure, count the boxes. You don't even need a ruler. Because remember, one box equals 1 millimeter. So one tiny box right here is 1 millimeter. Now, do you kind of make out how there's larger boxes? Those are 5 millimeters. Because it's 1, 2, 3, 4, 5 boxes across, it's 5 millimeters. So I can just count the boxes. If I need this, I can use this. And that's about 1, 2, say about 2. So say about 2 millimeters. Now, is you have to remember how do you get it into millivolts. That's the one where you always divide it by 10. Yep. So just divide it by 10, and exactly gives you 0.2 millivolts. Make sure you keep the unit. If on the practical, if you don't put the unit back in there, you actually will lose some points. So it has to say millivolts. Okay, so that was measuring the P. Let's measure the T. Now, I'm going to start, because remember that these boxes like here equal 5 mLs, or 5 millimeters. So I know that's 5, this is 6, 7, 8. Let's say about 8. Because I'm measuring from the top of here down. That's about 8. Yeah. So say 8. Again, same thing. You always divide by 10, and that will give us 0.8 millivolts. And the QRS, if you're measuring the QRS, you would measure up to here. baseline, don't go down to the tip, just baseline, measure up. Okay, now if you're going to do an interval, like what I have on the PowerPoint, the intervals, this is what you want in seconds. When it's asking you about seconds, this is what you're measuring across. Okay, so from the beginning of the P wave, before it goes up, right before it goes up, to right here, before this goes up, before the QRS goes up, this would be the PR interval. Okay, so to do this, I'm going to count my boxes again. Let's see, I'm going to count one of these 5. I can see that's 5. Wait a minute. 5, 6, 7, 8, 9. Yep, about 9 millimeters. But I don't divide by 10. This is the equation that's always 25 millimeters equals 1 second, and I need to get this in seconds. So you're dividing by 25, and whatever that is, seconds. It was like
What are you dividing by?
9 by divided by 25.
0.036. Is that right?
That didn't sound right.
It says 9 divided by 25.
Could we approximate?
Or point.
Okay, anyway, you get the idea on that. Okay, that's PR. Oh, who has the book? That book.
0.36.
Oh, I apologize. You know why? Because I just did it over there, and I thought it was like one. I don't know what I came up with. I'm sorry. She's like, I didn't. It's a calculator. Okay, you need to know this because you need to figure out whose book is this.
Mine, you can write in it.
Okay. Okay. So the PR interval. These are the only types of intervals you might have. Like I have a T and an ST up there, but you don't have it in lab manual, so you don't have to know it. It's just what's in here. Okay. Now here's where to measure from. The PR right before the P, you do not measure at the peak. That will be wrong. And then you go to before, or basically at this Q, right before the QRS complex. Now, in your, I mean, I can't even really make that out because there is a dip down and then it goes up. I can't see that here. But in the practical, where they draw it and it's going to be larger, you might.
Are you going to put these arrows first?
No, you don't get any of that. You have to. You're just going to get the electrocardiogram printout like this, and you have to figure the rest. Okay, so you would stop here and you'd measure across. If you're doing QRS, you also go from here, and then you would go to where it comes back, the top. Not the bottom peaks, or not peaks, whatever they are. Yeah, not the bottom points. Okay, everybody hear that? Not the bottom points. You have to go from where it's still up at the baseline. Okay. Again, on your printout, you may not see it, but in the lab practical, you will. And then the QT, again, go from here again, but you're going to go to the end of T.
Okay.
And then the TP interval is at the end of T to the beginning, right before it goes up, of P. So you see, for 1, 2, 3 things, we either end or start right here. Never using these bottom tips.
So the TP interval is more like